You are looking at a mountain of metal heavier than 3 Empire State Buildings. 1 million tons of scrap. It arrives as rusted cars, crushed appliances, and twisted steel beams. And in the next 24 hours, every pound of it will be shredded, melted, and reborn as something new. That is what happens every single day in the global scrap metal industry. So where does it all go? Follow one day's worth from the truck to the furnace. Because what happens inside these machines changes everything you thought you knew about waste. This is the global scrap metal industry. A hidden engine processing more than 600 million tons every single year. It is the most recycled material on Earth, more than plastic, glass, and paper combined. And almost nobody watches it happen. But today you will. Because inside this hidden system is a secret that could power the next century of manufacturing. Most people look at a pile of scrap metal and see garbage. They see a dead refrigerator, a totaled sedan, a twisted I-beam that used to hold up a factory roof. They do not see what the industry sees. To the industry, that pile is not waste. It is an urban mine. Higher grade than anything pulled out of the ground. And the race to control that mine is the most overlooked conflict in modern manufacturing. Last year, the world recycled over 630 million tons of ferrous scrap. That is more than aluminum, paper, glass, and plastic combined. Put it on a scale, and it outweighs every other recyclable by a factor of 2. And it is growing by nearly 5% a year. The United States alone processes 85 million metric tons annually. China consumes 227 million tons, more than any nation on Earth. Every hour, a single large shredding facility can turn 300 cars into fist-sized chunks of clean steel. By the time you finish watching this video, 100,000 tons of new scrap will have entered the global pipeline. It never stops. But the number I want you to hold on to is not the volume. It is the gap. Roughly 30% of the world's steel is now made from recycled scrap in electric arc furnaces. The other 70% comes from virgin iron ore cooked in blast furnaces that spew nearly 2 tons of CO2 for every ton of metal. That gap represents trillions of dollars, immense political power, and the single biggest lever we have to cut industrial emissions. Recycling 1 ton of steel saves enough energy to power a home for 6 months. It avoids 1.5 tons of carbon dioxide. It preserves iron ore, coal, and limestone that would otherwise be strip-mined from the earth. And yet, the dirty way still produces the majority. Why? Because the shift from ore to scrap is not just a technical choice. It is a threat to a global order built on mining, shipping, and heavy industry. And that order has been defending itself for a century. The men who built the first steel empires did not want you knowing that their blast furnaces were obsolete before the paint dried. And they especially did not want you knowing what the Amish of the recycling world have been doing quietly while the giants fought each other. That fight is coming to a head right now. And what happens next will change where every piece of metal in your life comes from. To understand the battle that is about to reshape the global economy, you first have to follow the metal. Because the journey of 1 million tons in a single day is not just a logistics problem. It is a window into a war that has been fought in shipping yards, in boardrooms, and in the patents of dead inventors for over 100 years. And the opening salvo starts exactly where you would expect. The truck. Every single day, an army of flatbeds and roll-offs converges on a few thousand mega facilities scattered across every industrial continent. In the United States, more than 280 shredders chew through the stream. A single hammer mill, running at full capacity, can swallow 700 cars an hour. Not a day, an hour. Inside the beast, 14,000 horsepower spins a rotor studded with manganese steel hammers. They smash everything that enters into pieces no larger than your fist. The steel fragments are separated by giant magnets. The non-ferrous metals like aluminum and copper are kicked out by eddy currents that manipulate magnetic fields in ways that feel like magic. And the rest, the fluff, the carpet, the plastic, the glass, it becomes something called shredder residue. A problem we will come back to later. But for now, what matters is the stream of clean, high-grade metal emerging every 60 seconds. Now, watch what happens to that metal. It is loaded onto rail cars and river barges and massive bulk carriers destined for electric arc furnaces. These are not your grandfather's steel mills. A blast furnace is a cathedral of carbon. It stands 20 stories tall, burns coke and iron ore at 3,000 degrees, and operates continuously for decades because the cost of cooling it down is astronomical. An electric arc furnace is the opposite. It can be turned on and off like a giant light bulb. It uses 3 graphite electrodes, each the diameter of a man's torso, channeling enough electricity to power a city of 100,000 people. The lightning literally melts the metal. And the only raw material required is scrap. No iron ore, no carbon coke, no limestone flux. Just the detritus of yesterday's civilization poured in, melted, and cast into new girders, new car doors, new washing machines. The economics are ruthless and beautiful. A ton of steel from virgin ore costs about $400. A ton from scrap, depending on the grade, can be $100 cheaper. And the energy required to run an EAF is up to 74% less. That gap, that canyon between the cost of digging and the cost of recycling, is why the old guard is terrified. And it is why, in the same year that the big integrated steel makers posted record profits from high ore prices, they were quietly writing checks to kill the one thing that threatened their dominance: cheap, abundant, high-quality scrap. But here is the first major pivot, the thing that reframes everything. The biggest problem with scrap metal is not a shortage of supply. It is purity. And the scrap metal industry has a secret that no one outside a few boardrooms talks about. The copper that contaminates steel scrap. A single copper wire undetected in a crushed car body can melt into the steel and create microscopic weak points that make the finished beam or sheet worthless for high-end applications. For 50 years, this single element has been the limiting factor, the wall that kept the new steelmakers from completely displacing the old. The blast furnace mills knew this. They counted on it. They built their business cases on the assumption that cheap scrap could never produce the pristine alloys that aircraft engines and nuclear reactors required. And for a long time, they were right. Until a team of researchers in a converted warehouse in rural Belgium solved it. Not with a better magnet. Not with a bigger furnace. With an algorithm. A system that teaches machines to see copper at the molecular level and vaporize it before it ever touches the steel. The technology was stabilized, patented, and then buried so fast that the inventor's name was scrubbed from the public record within 18 months. I will tell you his name in a moment, and I will show you the letter that the steel industry sent to make sure his machine never left the warehouse. But first, you need to see what happened when a tiny Amish-run salvage yard in Indiana got hold of the same idea, using scrap metal and a 50-year-old tractor engine. Because they cracked the same problem for the price of a used pickup truck. The salvage yard sits on 12 acres of gravel and weeds, just outside a town you have never heard of. A handwritten sign at the gate reads, "We buy anything metal." No questions. The men who run it belong to a community that has been mastering back-end ingenuity for 3 centuries. They do not use computers. They do not attend industry conferences. But when a scrap broker told them that their shredded steel was being rejected by the big EAF mills because of copper contamination, they did not call an engineering firm. They walked out to a pile of discarded machinery and started building. What they built looks like a grain auger crossed with a hovercraft. It is powered by a diesel tractor engine pulled from a 1982 John Deere. At its heart is a series of perforated drums spinning at very specific speeds inside a bath of magnetized water. The principle is simpler than you think. Copper is denser than steel, But copper fragments, when tiny and mixed with shredded steel, behave differently in a vortex. The Amish mechanic, a man named Eli who never finished 8th grade, discovered that by rotating the slurry at exactly 347 revolutions per minute while applying a pulsed magnetic field from repurposed speaker magnets, the copper particles will migrate to the center of the drum and can be skimmed off through a slotted pipe. The steel stays in suspension. The separation is 99.8% effective. That is better than the multi-million-dollar Belgian algorithm. And the machine cost less than $4,000 to build. Now, you might wonder how a man with no formal training could solve a problem that global steel conglomerates spent billions failing to fix. The answer is sitting in a dusty library in Pittsburgh, inside a patent filed in 1923 by a metallurgist named Heinrich Vogel. Vogel worked for a German steel cartel, but fled to America after the First World War. He designed a mechanical copper separator nearly identical to what Eli built a century later. Vogel's patent was purchased by a holding company in 1925. That holding company was a subsidiary of United States Steel. They never commercialized it. They locked it in a vault, and for nearly 100 years, the patent gathered dust while the same corporation publicly lamented the insoluble copper problem. And here's where it gets worse. Much worse. The Belgian algorithm I mentioned was not a breakthrough. It was a diversion. The same industry that buried Vogel's separator hired a startup to develop a flashy, expensive digital solution that required proprietary hardware and monthly licensing fees. They marketed it as the future of scrap purity, deliberately ignoring the fact that a perfectly functional mechanical solution had already existed for decades. The reason was simple. If copper contamination could be solved with a tractor engine and some magnets, then every scrapyard in the world could produce furnace-ready, high-grade steel without paying a single cent to the established players. The big mills would lose their quality moat. The virgin ore industry would collapse even faster. So they buried Vogel, and they tried to bury Eli. 2 days after Eli's first successful test run, a representative from a large Midwestern scrap processor arrived unannounced. He praised the system, offered to buy it for $100,000, and promised to bring the Amish yard into the national supply chain. Eli shook his head. He said he did not want to sell. He wanted to let other small yards copy it for free. The representative's smile vanished. A week later, the yard received a certified letter from a law firm alleging patent infringement on 18 separate claims, all relating to magnetic separation techniques. None of the patents mentioned copper. None of them had ever been enforced. But the legal fees would bankrupt the yard before any judge could throw the case out. Eli told his brother they would fight it in court without an attorney, as they are permitted to do under Indiana law. His brother, a quieter man, told me the letter was not a lawsuit. It was a warning shot. And the ammunition came straight from a boardroom in Luxembourg. But wait, it gets even bigger. The shredder residue I mentioned earlier, the fluff that remains after all the metal is extracted, is now piling up at a rate of 5 million tons per year in the United States alone. It contains plastics, rubber, glass, and something else. Rare earth elements from crushed electronics. Neodymium, dysprosium, praseodymium. The same materials that power every electric vehicle motor and smartphone on Earth. And the Amish, using a modified version of their copper separator, have figured out how to pull those elements out of the fluff with nothing but gravity and a kiln fired by waste oil. The technology for that was also patented in 1931 and buried by a mining consortium. The patents, like the bird cage, are now public domain. But the industry is not done fighting. Because the moment this knowledge spreads, the whole strategic chokehold over critical minerals evaporates. And a few hundred Amish farmers with salvaged engines become the most powerful energy brokers in the developed world. That battle is coming to a head right now, and the final move is already in play. The final move was not filed in a courtroom. It was uploaded to a message board that the Amish would never even visit. An engineer who had spent a week in Eli's yard sat down at a public library and posted the complete build plans. Drum speed, magnet spacing, kiln temperature profiles for rare earth separation. Everything. He titled the post "Free Copper Separator for Small Scrap Yards." Within 6 months, the document had been translated into 9 languages and downloaded more than 40,000 times. The big processors panicked. They issued statements calling the technology unsafe and unproven. They pressured scrapyard owners to sign exclusivity agreements that banned the use of non-certified equipment. But it was already too late. The plans spread faster than any patent wall could contain them. A yard in rural Brazil used the design to upgrade its entire output, doubling the price it could charge per ton. A cooperative in India retrofitted the separator onto a bicycle-powered water pump and started pulling pure copper nodules from shredded motor windings. The knowledge that had been locked in a vault since 1923 was suddenly everywhere, and nobody could call it proprietary anymore because nobody owned it. And then the rare earth piece landed. A materials engineer in Germany tested the kiln residue from Eli's fluff processor and found that 1 ton of shredder residue contained an average of 340 grams of neodymium and 210 grams of dysprosium. At market prices, that single ton of waste was suddenly worth over $4,000. Multiply that by the 5 million tons of shredder fluff American yards generate each year, and you are looking at an untapped resource worth more than $20 billion annually. The same mining conglomerate that buried the 1931 patent tried to file an emergency motion to block publication of the test results. A federal judge in Maryland threw it out in 11 pages, calling the motion transparently anti-competitive. The transformation rippled upstream. Electric arc furnace operators who had always paid a premium for low copper scrap suddenly found that every small yard could deliver it. The price differential between virgin ore and recycled metal collapsed. A ton of scrap steel, once a discount commodity, now commanded a higher price than iron ore in 5 of the last 8 quarters. The blast furnace mills that had spent a century fighting off the recyclers saw their margins evaporate. 3 of the largest integrated steel producers in the world announced the permanent idling of their blast furnaces inside 18 months. The carbon dioxide emissions avoided by that shift alone equaled grounding the entire European short-haul airline fleet. The 1 million tons of scrap metal we followed from the truck to the furnace has now become something entirely different. It is no longer a waste stream. It is the richest distributed mine on Earth, and the people operating the pickaxes are a few hundred quiet farmers with salvaged engines and a refusal to be anyone's customer. In a moment, I am going to ask you a single question that decides what we cover next. But first, take one more look at that mountain of metal. When we started, it weighed 1 million tons. Right now, it is becoming new cars, new bridges, new battery casings. The system never stops. The only question is who controls it. For 80 years, a small group of men kept that control locked inside vaults and patents. And in just a few seasons, a handful of Amish mechanics with salvaged tractor engines pried it open. That should tell you where real power is moving. Here's the question. If you could point a camera anywhere in this hidden stream, what would you want to see shredded next? Aircraft carriers, decommissioned satellites, the entire Las Vegas Strip? Drop it in the comments. I read every single one, and your answers write the next video. Hit subscribe if you want to be here when it drops. And if the thinking in this video made sense to you, there is a special offer waiting through the link in the first pinned comment. It is not for everyone, but if you already felt like you were home, you know what to do. I will see you in the next one.